Welcome to another TIRIAS cast. I'm Jim McGregor, one of the principal analysts here at TIRIAS Research, and I'm joined by my colleague and AI expert, Simon Solotko here. We're going to be talking about the hottest topic and the topic that's going to change the industry, and that's not just AI, but generative AI and eventually general artificial intelligence, where we actually have intelligence, kind of superhuman intelligence. So, Simon, you are the expert, so I want to introduce you really quick. He has developed a number of tools, not just models, but tools that help us analyze, the data center, the investment in the data center for AI, the equipment for AI, and kind of a forecast for AI and where we're going with this. So let's start off with the topic, and that is, first off, for anybody who doesn't know, you know, can we describe this path towards AGI?
Sure. The the hypothesis is that as we build increasingly capable neural networks, ultimately they start to provide parity with human level intelligence or capability. Now, that capability at first could be lumpy. They could be, say, good at figuring out how to prove a math theorem and bad at doing your laundry, right? There could be tasks where they'll shine or fail. But the general hypothesis is that neural networks, based on large language models and extensions of those, will ultimately be super intelligent. And that super intelligence is especially powerful because if you can do something once on a computer, you can do it 1,000 times. And so the theory is that we will create agents that are intelligent, that will collaborate together and be able to solve extremely challenging problems, as well as helping your kid with their homework.
Well, and we're already moving to that. It's a term that is being more commonly referred to as agentic AI. Obviously, Microsoft is trying to do that with Copilot. We're starting to see that with other solutions in the market as well. So we're already moving towards that. But the goal, as you pointed, is really get to that super intelligence or that human level intelligence or even beyond human level intelligence.
The theory and the reason people bounce between super intelligence and intelligence is they think if you get to human level intelligence, you throw more compute at it, you throw collaboration between large models at it, and you get to super intelligence almost for free. And this opinion has been voiced by others. So the thought is that once you get to human intelligence, you get beyond it very quickly. And as I had previously stated, if you get to that point, you might be able to trust, and I mean only trust in terms of intelligence, that these agents, by collaborating together, can work like an academic department does, collaborating, sharing results, and ultimately producing results that are better than any one agent could produce.
Or anyone human can produce, or even groups of humans can produce. Okay.
I've done in the modeling work, just cherry picking a data point. One of the things that we look at in our latest model and the tool that we're releasing publicly today is how many human experts could be fit into a server rack. And, the number I always come up with is in the several thousands. So you can imagine one rack of accelerated AI servers could produce the output of some entire academic disciplines. And we just have to get each agent or each instance of the model to be about as smart as a human researcher. And then we've got a gaggle of them.
You're kind of giving me an image here. I'm thinking of the circus clown car with a whole bunch of clowns coming out, but in this case, it's engineers coming out. But since you already went there, and we are just to let everyone know, we are going to talk about our forecast for where AI is going. But first, let's talk about exactly what Simon just introduced, these tools that we've developed. And these tools are very important. And once again, Simon is the expert on this and has spent a lot of time developing these tools. First, our forecast total cost of ownership tool for a lot of the hardware and data center applications, and now for generative AI. So you want to talk a little bit more about those tools, Simon?
Sure. So we developed two tools. So first, we had a history of looking at heterogeneous compute in the cloud, meaning putting accelerators that did specific tasks in the cloud and looking at the operating costs of those. We also previously had developed demand forecasts for various services like video streaming and cloud gaming. So when generative AI started to ramp, we realized we could apply these same methodologies. So first we built a model that looks at soup to nuts, global consumer and commercial demand for inference compute out of generative AI. And then it also looks at the workloads associated with that, the compute capability of the servers, and then ultimately the infrastructure or the cost of operating the infrastructure associated with that compute. So we call that model our FTCO model, as you just said. It's a model of year by year usage of AI as that demand grows and as the compute workloads grow and as the accelerators get faster. So certain things get easier, certain things get harder, and that ultimately results in what we believe the total amount of generative AI produced is. And our numbers are about 160x in 2028, what it was in 2024, and what the ultimate cost of operating that infrastructure is, which we estimated over $80 billion. So generative AI inference, just the running of the models, not the training of them, gets super big by 2028. That's the first forecast and forecast model we developed. We work with our clients to do scenarios like, if you don't believe what our model says, let's just change the parameters and get a different answer and understand what some of those sensitivities might be. As an example, video is really computationally expensive using generative AI to create video. And if that happens sooner, then the forecast gets bigger faster. And so that's an example of a variable in that forecast that we can modify. So that model we published at the beginning of the year. We wrote about it in Forbes, and that was a public disclosure. And there's a great infographic on that on TIRIAS Research. Skip forward to today. We realized that we didn't have the granularity we wanted in terms of understanding model size over time. And we were really curious, well, what is the roadmap for, say, ChatGPT and all these other models that are aspiring to AGI-like capability? So we built it. So we have built a tool that uses our conjectures or guesses about how these models are structured, what the inside of these models looks like, and those parameter counts, depending on the function of the model, are specified in there. And you can then use that to say, well, if I make certain conjectures, how big could these models be? How many parameters is required for every token of output? And how does that settle against the hardware that we forecast in the future as well? As we see NVIDIA and other accelerators getting faster, that allows these models to get bigger and still have the same throughput or cost of operations as in prior years. So that tool is designed to help people build full roadmaps for these AGI-like large language models through 2030. So that model is a 2020 to 2030 model, and it's an open tool, meaning we're providing it openly so that we can improve the discourse on the models that ultimately become these agentic AGIs.
Well, and I want to really highlight that point that these are really tools. So, I mean, when you look at the way we've done this, it includes all kinds of different parameters that you can tweak and you can add. You can put in different types of accelerators or characteristics for accelerators, what their performance level is. You can add in different characteristics, whether it's air cooled or liquid cooled data center. So we've looked at everything, kind of that, complete box and what's going to impact it. Matter of fact, we even have more research coming out on that. I'm doing a whole series on just designing for generative AI or designing for AI. And I've got a new one coming out looking at all those thousands of different things that are making the data center more efficient, especially for the AI era. So with that, let's go into some of our conclusions and what our forecast is from this. And I want to reiterate that this isn't just us. This has been kind of a collaborative effort with our customers, with some other analysts, with and using as many resources as we possibly can to enhance these tools.
Yeah, that's right. In this latest tool, which again is meant to roadmap what, say, ChatGPT and other large language models might look like as we go forward in time. One of the findings that I already pointed out was, that we can fit thousands of human equivalent researchers in a single rack in terms of output. And the way we model that is we figure how many pages of intelligent output uh, does each LLM instance need to produce in order to be a human equivalent? And then we multiply. And so it turns out that 4 well-written academic grade pages of research was kind of our ballpark for what a human equivalent output is. And then we were able to do the math. And again, it winds up being between, a few thousand and, 10 to 15,000 researchers as we go on time. Now, today, those researchers are, really very primitive compared to what they'll be in the future, right? AI models today are primitive. And it's a real disservice we're doing to them to give them such primitive nets and yet still require of them and all sorts of things and be very critical of them. But the truth of the matter is the underlying technology is moving forward quickly. There's nothing that I've seen so far that says the tens of thousands of very capable researchers are hitting walls in terms of moving that forward. So as we see that capability improve, we're seeing the underlying models get better and the quality of each of those agents improve, perhaps at some point to where they're almost human level. My belief is that for those agents to collaborate together autonomously, that's a hard job for them. And if I take OpenAI and let it talk to itself today, ChatGPT, o1, it does a pretty good job, but it can go spiral, and that will happen. So
Hallucinations.
hallucinations and even this AI to AI hallucination factor, where we
Yes.
see that when you train AI with AI, it doesn't go well. But the the theory is that as we converge to this human level intelligence, one litmus test is, can these agents work together without diverging or doing bad or crazy things? And so once we get there, we're going to see this cascade happen. We get to this human level, kind of capability, and then all of a sudden we're able to stick, 10,000 of them together on a server instance or a big instance of these things, and then uh, work to give them the tools and capabilities to collaborate. And that's going to be more training to get them to do that as well. It's like humans in an organization. You need organizational skills and people skills to work with others. These agents are also going to require that to achieve this collaborative intelligence.
Well, and some people are saying, we're moving from one technology to the next, but in reality, we continue building on that. I mean, we still have retraining, although they're pointing to some limitations on recursive retraining. We still have transformer models. They're still important. Some of the traditional models are still important. We're using a mixture of experts, combining these models. And RAG, this retrieval augmented generation is still important for using the latest information or what may be critical information for that query.
You're right when you say there are lots of tools to flex in producing strong outcomes for generative AI. The one distinction I like to make is if you want generative AI that's working in real time
Hmm.
or faster than real time, things like fetching data from a database, well, that requires some time to go fetch that data and creates latency in the response. Fetching something on a remote website is even more expensive from a latency perspective. So it's very interesting that having these really solid foundation models that kind of know a lot is super powerful. And I'd like to give one use case example. I built a catalog of my vinyl collection, and I was shocked that ChatGPT o1 was very good at guessing the catalog numbers of each record. In fact, it knew most of them. And that's kind of a weird level of capability. It wasn't looking that up in real time. I had created a RAG to do that to see if it improved that data access. But to think that you have just an AI who happens to have that granularity and specificity of knowledge, that's very powerful. And it creates low latency, right? I didn't have to wait for it to go fetch that data. And so it is interesting how there's an argument for super powerful foundation models. And then, of course, there's an argument for, if you can do it at a low cost, in particular, retraining them so that they get really good at doing something specific so that they never miss and so that they don't make mistakes.
So we're saying that AI is not hitting a brick wall. Completely agree with that. But when do we think AI is going to reach AGI?
You know, so what others say is within several years. And yet you'll hear people say, well, we're kind of already there. I'll just say this. If you look at the structure of a modern neural network, it's feed forward, meaning it's going from top to bottom, doesn't really have active memory or a scratch pad, just kind of has to divide it as it progresses through the layers of the neural network. And you compare that to how our brains function. Our brains look really complicated and super fancy. We're like a Maserati of neural networks. Complicated, hard to understand, difficult to fix. And so I think that there is so much room to improve the core structure of neural networks that we're still only at the dawn of the opportunity to make these things work extremely well, extremely efficiently, and that it will blow our minds. And so I think that the mind blowing is already happening. We have the first models that are capable of a reasoning step being generating tokens, either at the beginning or while they're going, that you don't get to see, but that help it scheme and conspire how to solve your problem for you. And in our model, we actually model the reasoning step. So in this latest LLM forecast tool, you can estimate how many tokens are required for these reasoning steps and build that into your logic for how many compute cycles are required to actually produce user results.
Now, you keep referring to tokens, but we are forecasting multimodal capability as part of that.
Absolutely. So even in the model, there's an estimate of how much multimodal capability do you need to use for each user request. A user request comes and in general, it's in one mode. These multimodal models may evoke different things, like it may want reference imagery to understand what you're talking about. So it may bring in multimodality, even if your original request doesn't look like it. But yeah, in the model, for instance, we do try to figure out how big is that multimodal neural network piece, in fact, pieces, and then how much is required for every user request.
Okay. Now, and I want to go back to the question because you didn't really answer it. So I'm going to put you on the spot, and I'm going to put myself on the spot. So it's not just you, but the obviously the definition of what AGI is very flexible. You know, what may be AGI to one person may not be AGI to another person, depending on how you look at it. So I'm gonna count to three, and you're gonna throw out a date, a year of when you think AGI is going to be feasible, and I'm gonna do the same thing, and we're gonna see how far apart we are. One, two, three.
In
2035.
2028.
Wow, you're more aggressive than I am.
And and I don't know if I'm aggressive enough. But the truth is there's going to be still so many deficits even when we get close that we're going to realize what problems we have left to solve. So that's why I've got it out in the middle of 2028. And we're going to have a lot of compute to leverage against it. And I think we will truly get to that human level of subtlety at that point in time. And what was your answer, Jim?
2035.
You're at 2035.
I'm a little bit, but I expect a lot when I say AGI. I
Mhm.
really expected to be more than able to do one function really well. I expected to do reasoning across at least, a dozen or more functions exceptionally well. So,
You know, it makes sense. When I look at um, the compute capability, which is one of the reasons why I built the tool,
mhm,
which is there's a bunch of variables. We can't keep them all in our head, so put them in a spreadsheet, right?
yeah.
And so when I look at the level of compute capability we expect in 2028, we're going to be several generations of accelerators out. Models will be able to be monstrously large, especially for high value problems. And I just think that the the capability of models today is so good that I think that the amount of compute we require to get them to that level where we start to scratch our heads and say, yeah, that's really a human behavior is not that far off. I also believe these are design choices. Um, a lot of the engineering around this is very hacker-like
True.
because we don't really understand how neural networks function. We know sort of how they function, but um, a lot of the work is trial and error to get training. Um, and inference to work. And that's a very hacker-like kind of engineering because the goal is just make it a little better every time. They
Hmm.
can have hypotheses about what'll make it better, but it's hard. I will point to one example. Today, when we train, these multi-expert models, it could be that every expert in the model converged, that they all just started looking the same. But it turns out because we're smart about how we architect the model, we've learned to ensure that they diverge and improve the function of the model. So today, ChatGPT o1 may have 8 experts and only maybe one or two, or four, we don't know, I guess two, is accessed at any given pass for any given token output. And it's just very interesting that it's these subtle design choices and trial and error experiments that are making these neural networks better. And that's going to continue for a long time. And that may be enough to hack our way to AGI.
True. Well, and one thing to point out is the fact that, just this demand driven by AI, is pushing us well beyond what we were achieving just with Moore's law. We're not going from single digit to double digits in terms of compute performance. We're doing hundreds and thousands of X increases or increases in performance and performance efficiency through completely redesigning data centers and systems and chips, everything, all the way down to, actually how we use these things. And we have a lot of technology that's going to probably make this even better going forward. Whether that's neuromorphic, whether that's quantum, whether that's whatever, this is pushing the innovation cycle faster than we've ever had.
So, to access these tools and some of our research, you can go to tiriasresearch.com/research. And we've got the FTCO infographic there. And we just posted our new LLM forecast tool there as
Mhm.
well. The tool is a little hairy at first, but if you'd like more information, just feel free to reach out to us and we'd be glad to brief your team and talk more about it. But those tools are available to you, so you too can start to think about and opine and build upon some of the knowledge we've accumulated so far.
Yes, and to reach out to us, either reach out to Simon at TIRIASresearch.com, Jim at TIRIASresearch.com, that's TIRIAS Research, up there in the window.com, or even Francis, for Francis Sadeko at Francis at TIRIASresearch.com. Simon, thanks again. We're going to be doing, just to let you know, everyone know, we're going to be doing a lot more of these because the level of innovation continues to increase, and the level or the information that we're generating out of these tools is phenomenal. So look for more of that, look for updates to the tools, and look for more Tirias cast from us on these topics. Thank you.
Jim.